Here we'll explore how to solve equations like 4x equals 20. As a first step, let's guess an answer and see what happens. If x equals 3, then what does 4x equal? If you're not sure, click down here to review. Right, if x equals 3, then 4x equals 12. But we wanted 4x to equal 20, so 3 is not the right answer. What is the right answer? Solve this equation for x. Nicely done. X equals 5. So you can guess different answers and check to see if they work. But let's come up with another way to solve equations like this one. First, consider the equation y plus 3 equals negative 2. What step can you take to solve for y in this equation? Should you add 2 to both sides, subtract 2, add 3, or subtract 3? And click here if you're not sure. Exactly. To solve this equation, you should subtract 3 from both sides, because once you do this, adding 3 and subtracting 3 on the left side cancel out, and that leaves you with y. So y equals negative 2 minus 3, or negative 5. So getting back to this equation, we want to do something to both sides to get rid of this 4 in front of the x. So let's divide both sides by 4. On the left, the 4 in the numerator cancels out the 4 in the denominator, leaving us with just x. So x equals 20 divided by 4, which equals what? Right, so x equals 5. This is the same answer you got before, but when you solve for x like this, there's no guessing involved. Try some more examples. If 5a equals 15 and 6b equals negative 42, solve for a and b by dividing both sides of these equations by the numbers in front of the variables. Nicely done. Dividing both sides of this equation by 5, you found that a equals 3. And dividing both sides of this equation by 6, you found that b equals negative 7. So how about the equation 3x equals 7? Well, to solve for x, we can divide both sides of this equation by 3. So x equals 7/3. 7 divided by 3 is not a whole number, so we could leave our answer like this as an improper fraction, or we could equivalently write it as a mixed number, 2 1/3. Try solving a few more equations whose answers are not whole numbers. You can write your answers as improper fractions, mixed numbers, or decimals, or click here to review. Excellent! Dividing both sides by 2, you found that a equals 9/2, or 4 1/2. And over here, dividing both sides by 5 means that b equals negative 8/5, which is the same as negative 1 3/5. Okay, so how can you solve equations like this, where the variable is being divided by a number? Well, let's now multiply both sides by 3. So on the left, the 3 up here cancels out the 3 down here, meaning x equals 4 times 3, or 12. Try multiplying both sides of these equations to solve for a and b. Excellent work! So a equals 8 times 2, or 16, and b equals 5 times 6, or 30. Next, here's an equation where the variable is being multiplied by a fraction, 4/5. So how can we solve this one? Well, let's multiply both sides by the fraction's reciprocal, meaning we flip the numerator and the denominator. So we're multiplying both sides by 5/4. Why are we doing this? Well, let's look at this part of the equation over here. What's 5/4 times 4/5? And to review multiplying fractions like these, click down here. Exactly. The 5's cancel out and the 4's cancel out. So this product equals 1. And that means x equals 24 times 5/4, which equals what? Right, so x equals 30. Now try solving these equations. 3/7 a equals 12 and 2/3 b equals 5. Nicely done. So a equals 28 and b equals 15/2, or 7½. Now let's apply this approach for solving equations to a real-world problem. Suppose a pair of jeans is on sale, and now it's only 3/4 of the original price. If the sale price is $36, then what was the original price of the jeans? If you get stuck, click here and we'll figure this out together. Excellent! There were a few different ways you could have solved this. One way is to call the original price of the jeans P. Then the sale price is 3/4 of P, which means the sale price is 3/4 times P. And the problem says that's equal to $36. So we have an equation that we can use to solve for P. The reciprocal of 3/4 is 4/3. So if we multiply both sides of this equation by 4/3, then the 4/3 and 3/4 cancel on the left side, so P equals $36 times 4/3, or $48. So that means the original price of the jeans was $48, and you'll be saving $12 with the sale. In this lesson, we'll introduce cross multiplication and use it to solve equations. First, take a look at this equation. X over 4 equals 5. Try solving this equation for x, or click down here to review. Right, to solve this equation, you can multiply both sides by 4. Then the 4's on the left side cancel, meaning x equals 5 times 4, or 20. Multiplying both sides can also help you solve equations like this, where the variable is in the denominator. If we multiply both sides by y, then the y's on the left side cancel. So then 12 equals 3 times y. To solve for y, we can divide both sides by 3. Now the 3's cancel, and y equals 12 divided by 3, or 4. Try using this approach to solve two more equations. 8 over a equals 4, and 3 over b equals 5. Nicely done. So a equals 2 and b equals 3/5, or 0.6. Now what about an equation with fractions on both sides, like 4 over x equals 6 over 3? How can we solve this? Well, first, let's multiply both sides by x, and the x's on the left cancel out. Then we can also multiply both sides by 3, and the 3's on the right cancel out. And so 3 times 4 equals 6 times x. Let's look at the original equation again. Over here, we're multiplying 3 and 4, which were the numerator and denominator on different sides of the equation. And over here, we're multiplying 6 and x, which were the other numerator and denominator in the equation. So whenever you have two fractions that are equal, you can cross-multiply. Multiplying each fraction's numerator by the other fraction's denominator will always give you the same result. To solve this equation, 3 times 4 is 12. Then we can divide both sides by 6. So x equals 12 over 6, or 2. Next, suppose you're given the equation 5 over 2 equals a over 4. Try cross-multiplying in this equation to determine which of these other equations for a must also be true. Excellent! So if we cross-multiply in this equation, then 5 times 4 equals 2 times a, which is this equation down here. So go ahead and solve this equation for a. Right, 5 times 4 is 20, and then dividing by 2 gives you the correct answer of 10. Next, try using cross-multiplication to solve these equations for x and y. Great! So when you cross-multiply in this equation, you found that x equals 21 over 4, or 5 1/4. And cross-multiplying this equation, you found that y equals -4. Now it also turns out that many word problems can be solved with cross-multiplication. Here's an example. You're writing a novel. If you write 5 pages every 2 days, how long will it take you to write a 250-page novel? If you get stuck, click down here. Excellent work! There are a few different ways you could have solved this. Let's look at one of those ways. So it takes you 2 days to write 5 pages, and we could say it takes you X days to write 250 pages. And the key here is that the rate at which you write is always the same. That rate equals 5 pages divided by 2 days, and it also equals 250 pages divided by X days. Both of these expressions should give you the same rate of pages written per day. And now you have an equation that you can solve using cross multiplication. 2 times 250 is 500, and dividing by 5 gave you the correct answer of 100. So if you write 5 pages every 2 days, then it will take you 100 days to write the entire 250-page novel.